Good afternoon, everybody. Welcome to, well, it has been rainy Monday, but it stopped raining Monday afternoon at Chem 170 with your host, me, Dr. White. By the way, in case you're wondering why I do the countdown, because that allows me to clip off stuff easily at the beginning where I do my video editing. I found that was easier than trying to find where do I say hello. So, all right, lot to do. But first of all, let me say something. By the way, if you turn on your screen, your webcam makes me feel better. Oh, thank you. All right, let me tell you something about the lab questions. My lab questions are straightforward. I don't try and trick any, well, maybe just a tiny, but I don't write them to trick you. Read them, then just answer it directly as it is. Now, as two of your colleagues have recently done, if you have any questions about the questions on a lab or anything else in my class, ask. Remember, in my class, there's no such thing as a dumb question. In my world, there's no such thing as a dumb question. So always feel free to ask. You can ask during lecture, after lecture, come to my office hours on Tuesday and Wednesday from 6 to 7:15, or email me or ask, can I set up a special Zoom meeting? And if I'm available and you're available, I will. All right. Now, today I promised to go through the ethers and epoxides problem set. And I better keep my promise. I do. So let's do it. All right. Now, if you notice, I don't have any nomenclature because, can you keep a secret? Shh. I usually don't put ether nomenclature on my tests. Shh, as a secret. But in case you don't want to feel like you're getting cheated, let's do one. And here's one for you to try. Give the common name for that molecule. Name each R group as an alkyl group and add the word ether. Oh, I gave away the answer. Don't forget the hand in the lab. That's due Wednesday. And if for some reason you happen to hand in the other labs, contact me. You should hand those in. Labs are, I don't want to say it this way, but really are easy points, a lot easier than on a test. But you got to hand them in. All right, looks like everybody's done. Look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen. Carbon's here, they're different. This is an ether. And I could call this methyl, common name we're doing. This is the N-propyl ether. Now, since this is a common name, there are no rules. You could have put the N-propyl first. Oh, let's do one more. And here's one more. Give the common name for that molecule. I remember during my class, if you want to ask questions, either turn on your mic. I have checked if my speakers were on. When I first started doing Zoom, I forgot to turn my speakers on. I can't hear you. What did you say? Well, I had to turn on my speakers. And don't forget to vote. All right, let's take a look at this. What do we have? Oxygen, carbons here and here. It's an ether. And what do I have here? An ethyl group. Ooh, I have another ethyl group. How do we do that? Diethyl ether. And this is probably one of the most widely used ethers, period, in chemistry and also other places. And let's get to the problem set. All right. And I should mention before we start this, I think it's coming up next week. I'll look during the break of my syllabus, test number 2. Test number 2, and if it is next week, by Friday or sooner, I will put out an email with the point breakdown, but it will cover alcohols, thiols, ethers, epoxides, really ethylene oxide, and aldehydes and ketones, my favorite. So Mother Nature's too. And like test number 1, there'll be 3 major areas. 1, general knowledge. 2, nomenclature. Remember, there are 2 types of nomenclature problems. Here's the structure, give the IUPAC name. Here's the name, draw the structure. And it will have reactions. Most of the points in the reactions will be give the organic product or products. But unlike test 1, instead of 1 synthesis problem, give the starting material, I usually have 3 or 4. If I did any more, that'd be cruel, unusual punishment. I think it's still outlawed by the Supreme Court. All right, give the product or products for a following reaction. And if we look at A, what do we have? Oh, what's different? Oxygen with a minus sign, sodium cation, and carbons on that oxygen, alkoxide. I'll never ask you what an alkoxide is. Next, carbon, carbon, carbon. Ooh, iodine, a halogen. And that's an alkyl halide. And this is a Williamson ether synthesis. And if you take an alkoxide, alkyl halide, that should be R prime X, you get an ether plus a salt. But I'm only asking for the organic, so you don't have to put down the salt unless you want to. That's okay by me, but you don't have to. Remember, the oxygen O minus bonds to the carbon with the halogen. The oxygen OR minus bonds to the carbon with the halogen. In this case, the end of 3. So you don't break carbon-carbon, single bonds. R methyl, oxygen, R prime and propyl, but it's to the end carbon. If we look at B, oh, I got a fancier R group, but it's OR minus Na plus. The second chemical is an alkyl halide. Notice the bromine is on the middle carbon. The oxygen bonds to the carbon with the halogen and kicks that out. Notice how violent organic chemists are, kicks it out. We actually, if I were colleagues, I'd use that terminology. And what's our cyclohexane ring? What's our prime? An isopropyl group. So the oxygen here goes to the center carbon of 3 carbons. Now, the next are the same. And before I go to D, let's do one more. But before I do that, I'd like you to stop and think about something. I just said isopropyl. I just said cyclopentane ring. 6-8 months ago, would you even know what I was talking about? Aren't you proud of yourself, how much you've learned? You should give yourself a pat on the back. All right, now, on test 2, I'll have a couple synthesis, so let's have some fun. And here's one for you to have fun with. Remember, synthesis is the best part of organic chemistry, but I'm biased because I'm an synthetic organic chemist. Give the starting material or materials for that reaction. And on a test, I'm nice. Don't tell anybody I'm being nice. But if there's more than one starting material or a product, I'll put 2 question marks or whatever. Your turn. In real life, at chemical companies, this is what chemists, organic chemists do in research and development. How do I make this chemical? Because we need it to sell, because people want that product or need it in other products. And for those who are finished early, please be patient. And this is one hydrogen in a bond. All right, everybody, looks like everybody's done. How do you proceed? Well, whenever I look at an organic molecule, I look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond gets my attention like that. And, ooh, an oxygen here. And this is inorganic, but this is a salt. NaX, X can be chlorine, bromine, which it is, or iodine. And then oxygen, carbons here are prime. It's an ether. What two things do you react to make an ether? Well, the Williamson ether synthesis, an alkoxide, and an alkyl halide. So I'll call this R and this R prime. If I do that, that's my alkoxide. And since you end up with 4 carbons in R prime, you better start with 4. And notice the second carbon here, I'm drawing it this way, has the oxygen. So that's going to be the carbon with the halogen. The halogen we get from there is a bromine. I know there are 4 bonds to carbon. That's always going to be your friend on any test. And I can put in the hydrogen. Am I done? No. I could just as easily call this R prime and this R. If that's the case, the carbon with the oxygen is the carbon in R with the O minus there. So I have 4 carbons. Which carbon has the oxygen? This one will be O minus and A plus. I don't know why, but I'm inconsistent. I always circle a negative charge, never a plus charge. Well, good habits, I don't change. And R prime is an ethyl. And I almost messed it up. And it will have the halogen bromine. And the question is, which is correct, A or B? And the answer is either one for this class. If you're doing a synthesis, you could do either one. And in business industry, whichever one has the lower cost starting materials, that's the one you'd use. But on my test, I don't expect you to know cost accounting. Most of the chemists and academics don't. But I've had many decades experience in the chemical industry. All right, couple things before we move on. One, do you happen to drive by a gas station, think they sell gasoline that contains up to 10% ethanol, which is an alcohol? Do you happen to pick up a bottle of rubbing alcohol and see it has isopropyl alcohol? That's an alcohol. Did you happen to look at a bottle of nail polish remover and it has acetone? Say I forgot to polish my nails, but I'll never be a hand bottle. That's beside the point. And that is, all right, you should remember organic chemistry is all around you, and it won't hurt for you to think about it. Now, quick, not going to be on test or anything. Last night I was watching a program on cable TV, Food That Made America Great or something like that. It's a fantastic program, shows ingenuity at its highest level, how people created, men and women, different important foods in our daily life. And there was a commercial, and they were showing a new lip gloss that lasted a long time. I guess the term they didn't use it would be durable. And it said, our new vinyl lip gloss. And I said, oh, my class would know what vinyl is, even though I wouldn't put it on a test. That's a double bond, CH2, double bond CH attached to something. And I can tell you this, personal care products and cosmetics are high-level organic chemistry. I won't show it to you now, but over the last number of years, the new mascara that's come out that's more water resistant, that's organic chemistry. All right, let's get back to the problem set. All right, next one, D, give the organic product or product for the following. And here, what's different? Alcohol, ethylene oxide. And alcohol, ethylene oxide, you get this ether alcohol, ROCH2CH2OH. What's R? N-butyl. The carbon with the hydroxyl group is the carbon in R with the oxygen. Do you break carbon-carbon single bonds? No. And 4 carbons, oxygen, CH2CH2OH. This reaction I'll never give on a test or a final, a synthesis problem. That's not right. Now, if we look at E, fancier R group, fancier, scary if you don't know what's going on, syn alcohol, ethylene oxide. Here's my R group, oxygen, CH2CH2OH. Now, if we look at G, I've got a benzene ring, but benzene will not react with, 9 moles or 9 molecules of ethylene oxide, but carbon with an OH group, that's an alcohol. Excuse me. And here, R is the benzene ring. And the general reaction is alcohol, N moles of ethylene oxide, and you get this polyether alcohol. Listen carefully. Common mistake. Students put the OH inside the bracket. Wrong. I'll say it again. The OH is wrong if you put it inside this bracket. Needs to be on the outside. And the subscript N comes from the coefficient of ethylene oxide. R, benzene ring, O, CH2, CH2, close bracket, 9, OH. And here I just give you a different R group. N is 5, same reaction. OH group goes outside the bracket. Now, I have a couple of synthesis problems here. We already did one. And if you look at C, cross it off. I shouldn't have done that. Bad, Dr. White. But if we look at A, what two things give you, that's why there are two question marks, do react to make this compound plus sodium bromide? What's different? Ether plus a salt, sodium bromide. This the Williamson ether synthesis, alkoxide OR minus Na plus an alkyl halide. I don't have here, but X can be chlorine bromine iodide. And you make an ether. The carbon with the halogen and R prime is a carbon the oxygen is bonded to in your ether. So I can call methyl R, ethyl R prime, and you get the top. If I switched it, call F methyl R prime and ethyl R, you would get the bottom. And either one is right. And we're done with that. Any questions? Speakers on. Well, in that case, let's get back to ketones and aldehydes. And let me just remind you, oops, wrong color. And we have an aldehyde. Remember, this is a carbonyl. Carbon double bond oxygen. You should know. You should know how to write and describe with the words what's a carbonyl group. And you should know don't you love it when I'm subtle? You should know how to draw and describe with words what's the carbonyl group. Here's how you draw it, carbon double bond to oxygen. Here's how you describe it with words. You can either say carbon atom double bond to an oxygen atom, or as I just said, carbon double bond to oxygen. Now, we were starting to talk about, I don't know if time for me to share something personal. Did I tell you if somebody came up to me and asked, Dr. White, what kind of chemist are you? If I were being totally honest with that person, the only answer I could give is, I'm a carbonyl synthetic organic chemist. All the work I did in my PhD thesis dealt with carbonyl groups. My first and last patent dealt with carbonyl groups, and some of my other patents dealt with carbonyl groups. They've been good to me. I've been good to them. Now, you know I'm an organic chemist. I love carbonyl groups. I don't want that. All right, last Wednesday, before we did the lab, we talked about formation of hemiacetal, hemiketal. So here's general reaction. This reaction, I will never give synthesis. I will expect you to know. And the reaction is if you take a ketone, or R prime is hydrogen, an aldehyde. So it's both an aldehyde or ketone plus an alcohol reacted with an acid catalyst. And that could be sulfuric acid. And there are other acids I'm not really going to cover this semester that I've worked with, like paratoluene sulfonic acid, methane sulfonic acid, an acid proton donor, H+. You react it, keep your eye on the carbonyl carbon. That's where the fun is. What's attached to it, because you don't break carbon-carbon single bonds, is still attached to it. And this opens up the hydroxyl group on that carbon, and from the alcohol, OR. And we did some last week, but let's try one more. And here's one for you to do. Give the organic product or products for the following reaction. Remember, these are the building blocks organic chemists and Mother Nature uses to make things. And later on, you'll see this is how Mother Nature, the first step, now with these two chemicals, but a carbonyl aldehyde or ketone plus an alcohol makes carbohydrates. You know, the good things in life, French fries, potato chips, everything I don't need. Oh, rice and potatoes, those are good too, I like them. And please be patient. I try and give everybody time to finish. All right, let's move forward. How do we determine what's the product or products of this reaction? You look at the starting materials. What's different? What's not carbon? Ooh, oxygen carbonyl, to double bond to carbon, carbonyl, carbons here and here. And this is a ketone. Now it's cyclic. R prime and R double prime are connect together in a ring. It could have been an aldehyde if R prime is hydrogen. It's not. Oh, you know what I forgot to do? I'm sorry. H plus. Somebody should have caught me there. All right. And what's different here? Hydroxyl group on a carbon. That's an alcohol. And acid catalyst that Dr. White forgot. Hold on. Bad Dr. White, bad Dr. White. Anyways, what do you get? Keep your eye on the carbonyl. What's attached to it stays attached to it. This opens up to OH group on that carbon plus OR. This whole thing here, this ring, is our R double prime, R prime. So it's still going to be there. You're not going to break carbon-carbon single bonds. This carbon is this carbon, which is this carbon. We'll have a OH, oxygen. What's our R group? Comes from the alcohol. The carbon with the hydroxyl group will be the carbon this oxygen is bonded to. The carbon with the hydroxyl group in the alcohol will be the carbon oxygen is bonded to an R. And notice that's the center of 3 carbons. And I'm done. And that's how you do it. And let's move on. Now, if you look at this small reaction, you're reacting 1 mole when there's no numbers, it's 1 with an aldehyde or ketone. If R prime is hydrogen, it's an aldehyde, this carbon's ketone. There's a carbon there that makes your carbonyl. Now, what happens if you take an aldehyde or ketone and react it with 2 molecules of an alcohol and acid catalyst? Now you form an acetal or ketal. This is one of the key reactions Mother Nature uses to make carbohydrates, the one before and this one. And later in the semester, we'll go through actual carbohydrate formation. Oh, it's fun. Keep your eye on the carbonyl carbon because that's where the fun is. And it does happen there. What's attached to it, R prime or hydrogen, and R double prime is there. And now instead of OH and OR, because you have 2 alcohols, you'll have 2 ORs on there. Now, unfortunately, I don't have time in a 16-week class to go through the mechanism. What happens step by step? It's exciting, but I'm a synthetic organic chemist. Every reaction I show you this semester, I can do the mechanism. One of the reasons my PhD advisor when I was in grad school, Dr. Rouge, who I will forever be grateful to, because he taught me and all the other people in the group too, how to become a synthetic organic chemist and helped me create a strong foundation in organic chemistry in my brain. He used to always beat into mine and everybody else's brain, you have to understand the mechanism, what's going on. Well, I can't do that in this class. But anyways, let's look at this reaction. And this reaction, I will never give a synthesis problem with. And the question is, what's the organic product or product for the following reaction? Well, you look for what's different. What's not carbon, what's not hydrogen. Ooh, oxygen, double bond to carbon, carbonyl. It's got a hydrogen. It could be R prime or hydrogen, but it is a hydrogen. And it's got carbons, R double prime. In our case, this is an aldehyde. Could have been a keto. Ooh, the number 2, that's unusual. And carbon-carbon hydroxyl group, alcohol, acid catalyst. Keep your eye on the carbonyl carbon. Comes this carbon, what's attached to it? Stays attached. And to that carbon, you get 2 ORs. The carbon with the hydroxyl group is the carbon this oxygen is bonded to. So if we come up here, R prime, R double prime, you can switch them, doesn't matter. I call this R double prime or H, but I tend to write it this way. So here's my carbonyl. I'll draw this carbon. What's attached to it are hydrogen, R prime, and then 2 oxygens. And what's my R group? You look at the alcohol. And it's an ethyl group. And that's how you do it. And that's the molecule you make. I better share some fun. And here's some fun for you. Give the organic product or products following reaction. 3 points each. And by the way, thank you for all coming to our lecture today. And please be patient. Try and give everybody time to finish. One time in class, when I was young, my father used to teach me a smart person is never bored. And he challenged me just when I was about 5. How do you do one finger forward, the other backward? And then if you finish early, you can do this. Then you do it with your thumbs, one forward, one backward, not like this, one backward. And then after that, he could wiggle his ears. And it took me a number of months to find the muscles right back here where I can wiggle them. And I can even wiggle one or the other. Great achievement when I was 5 years old. See, I told you to learn things you don't want to learn about, Dr. White. All right, let's get going. If we look at this, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention. Carbonyl. Hydrogen, but it could have been R prime. Carbons here, R double prime. Ooh. Coefficient, the number in front is called coefficient 2. Carbon hydroxyl group alcohol. Acid catalyst. That's better. And keep your eye on the carbonyl carbon. That's where the action has. What's attached to it, our prime, our hydrogen, our double prime stays there. And because you have not one, but two alcohols, you get on that carbon that was the carbonyl carbon 2OR. And I'll call this our prime, our double prime, and on the alcohol, the methyl group R. Write this carbon first, because that's where all the action is. What's attached to it, hydrogen and ethyl. And then, because you have not one, but two alcohols, oxygen, oxygen, what's our methyl? And that's the product you get. Oh my goodness, time flies when you're having fun with carbonyl groups and ethers and epoxides. Let's take a 5-minute break. I'll see you in 5. I can get up and stretch. See you in 5. Let me remind you, the reaction I did with one molecule of an alcohol, an aldehyde, and ketone, and now we are working on two, are two of the more challenging ones you'll see in the next two this semester. All right, we're just looking at this reaction. And let's do another one. And here's another one for you to have fun with. Give the organic product or products that are following. And remember, I give everybody time to finish, so please be patient. All right, let's get going. And if I look at this reaction, what's different? What's not carbon? What's, carbon, double bond oxygen. What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? A carbonyl. It's got carbons here and here. They're connected, but this is a ketone. Could have been an aldehyde. 2 coefficient carbon, 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 oxygen with a hydrogen and a carbon, that's an alcohol. And I have acid catalyst. And now, what do you get? Keep your eye on the carbonyl. What's attached to it will still be attached to it. R prime or hydrogen, R double prime. Then, because you have two alcohols, two oxygens to this carbon, and each one will have the R group from the alcohol. Now, in a ring, R prime and R double prime are connected together. This carbon is my carbonyl. So I can get it back. And what's attached to it is still attached to it because you don't break carbon-carbon single bonds. Now this carbon will have two oxygens. What's my R? And propyl. The carbon with the hydroxyl group will be the carbon this oxygen is bonded to. And that's the end carbon of 3 carbons. And that's the molecule you get. All right, let's move on, unless there are any questions. Guess not, so let's move on. Now, once you make a hemiacetal, remember this is a carbon here, and if R prime is a hydrogen, it's a hemiacetal. I'll never ask you names on its S. R prime is alkyl, it's a hemiketal. If you react it with water, well, everybody knows what H2O is, and acid catalyst. You get back the aldehyde or ketone you would have started with, plus the alcohol you would have used to make that hemiacetal, hemiketal. Now, before we go forward with this reaction, or actually, let me write it on the whiteboard. Let me ask a question to all of you for you to think about. Right now, in the room or place, wherever you are, where would you find acid water? Again, right now, in case of for me, in my office, where would I find acid water? Or where would you find it where you're sitting, in the room you're in? And the answer is your stomach. My stomach and your stomach, I think it's one of the great miracles of life, have cells in there that make hydrochloric acid. Plus, you've been drinking water, I hope, today. I have. And so in my stomach and your stomach, we have acid, H+, plus water. And the next two reactions are how your body, your stomach, breaks down. I think someone corrected me years ago. It's either your large or small intestine also does it, has acid present, breaks down carbohydrates. So if you had a piece of bread, or if you had rice, potatoes, or the good stuff, French fries or potato chips, which Dr. White needs like a hole in my head, which I don't. These are reactions Mother Nature uses to break down your food. So let's take a look at an example. And let's look at this one. The question is, give the organic product or products, and I do question mark plus question mark on a test to help you out. Don't tell anybody I'm being nice. Shh. But anyways, look at the starting material here. What's different? What's not carbon? What's not hydrogen? Ooh, oxygen here and one here. I have an OH, oxygen, and on that oxygen up here, I have carbons. And to this carbon, I have carbons, R prime, could have been hydrogen, and R double prime, hemiacetal, hemiketal. Water, acid, keep your eye on this carbon with two oxygens. It becomes my carbonyl. And you'll get an alcohol too from this right up here. So if I look here, I'll call that R prime, this R double prime, and here we have R. So this carbon is this carbon, forms a carbonyl. What's attached to it, R prime, methyl, R double prime methyl. Next, what's R? Ethyl, the carbon with the oxygen here is the carbon the hydroxyl group will be on. So I'll get ethanol. Again, keep your eye on the carbon with the two oxygens. That becomes this carbonyl. What's attached to it, R prime and R double prime, are still there. And my R group is this alcohol. And that's how you do it. Not to scare you, but not with this molecule, but others more complex. That's happening in your stomach. You had carbohydrates recently. I did scare you, maybe I shouldn't have. What two product or products would you get from the following reaction? 3 points each. And this reaction, I will never give a synthesis problem on a test or the final. I promise you, but more importantly, I promise myself. I don't know if I told you this. I don't think I've ever broken a promise to someone else, but I know I've never broken a promise to myself. Never. So if I promise something to myself, you know I'm not going to break it. And if I promise to you too, I won't either. like I said, this one's a little more challenging. We're getting into more juicy, good stuff, but because it's juicy and good, that sounds like a commercial. But anyways, it's sometimes a little more challenging. I have faith in you. You can do it. All right, let's move on. My turn. We look at this molecule, what's different, what's not hydrogen, what's not oxygen. Anybody having nightmares hearing me say that? Hope not. But anyways, this is what I look at when I look at a molecule. Ooh, carbon with hydroxyl, oxygen, carbons here. This could be R prime, but it's hydrogen. And carbons here are double prime. A hemi, in our case, R prime is hydrogen, a hemiacetal, water, acid. Look at this carbon. What's attached to it, R prime or hydrogen. Our double prime is still there, and it becomes a ketone or aldehyde you would have used to make this. Plus, from here, you get this alcohol. And hydrogen R prime, ethyl R double prime, on the oxygen CH3 methyl R. Keep my eye on this carbon, which becomes this carbon, which becomes this one. What's R prime, hydrogen? What's R double prime, ethyl? And my alcohol, my R group is methyl. And that's how you do it. Oh, let's do another one. And what two compounds would you get if you react that molecule with acid and water? Acid, H plus, water, H2O. And remember, I give everybody time to finish. So please be patient. All right, let's get going. We look at this molecule, what's different, what's not carbon or hydrogen, and we have, oxygen, hydroxyl on the same carbon. I'll call this R. I have carbons here and here, R prime, but one, it could have been a hydrogen, it's not, and R double prime. And here we have a hemiketal. And we're reacting with acid and water, or water and acid. Doesn't matter which you first or second there, because it's a mixture. And keep your eye on this carbon. The R group are hydrogen, R prime are hydrogen, R double prime, and this becomes a ketone or aldehyde, carbon double bond to oxygen, carbonyl. And this R on the oxygen becomes this alcohol. Essentially, you're taking the hemiacetal or hemiketal and reverting it back to the aldehyde or ketone, plus the alcohol you would have used to make that. Now, this carbon is this carbon. We have this ring. Don't forget the methyls. You don't break carbon-carbon single bonds. This carbon is this carbon. So we'll get that ketone. Then my alcohol, R prime, or R, I mean, is ethyl. And that's the product you get. And again, I'll never do a synthesis problem for this type of reaction. Now let's move on. Turns out, I call it reversing. You could also call it acid hydrolysis of an acetal or ketal. And this reaction your stomach uses also to break down carbohydrates. And if you take an acetal when R prime is H, ketal when R prime is alkyl carbons, acid and water, or water and acid, you get back to ketone or the aldehyde. There should be H plus H there, plus 2 alcohols. Now, you don't have to put the 2 there, because on my test, I ask, give the product or products. And let's rewrite it. And keep your eye on the carbon with the two oxygens. That's different. And that becomes the aldehyde or ketone you would have used to make that. And from the OR, you'll get your alcohol. Now, I'm going to write it as tiny as I can with quotes. You don't have to put a 2 there. Now, a number of years ago, I was teaching organic chemistry. I had a pair of twin sisters, identical. Personalities were pretty close too. And they would go ballistic, get really upset if I didn't put that 2 there. Where's the rest of this stuff? And so to make them not go ballistic, I would put a 2 there, but write it real little. You don't have to. I should inform you, over the years, I think I've had 4 sets of twins in chemistry classes, 3 at the same time, and 1 2 years apart. I remember I was teaching Chem 170, and I looked at the class the first day. I asked this one student, could you talk to me after class? I said, you look familiar. Didn't you take this? She said, no, that's my twin sister. And her twin sister came in another time, and oh, are they identical twins? And the question is, give the organic product or products are the following. And you look for what's different. Ooh, what's not carbon, what's not hydrogen? To the same carbon, 2 oxygens. And each one has carbons on it. We have a hydrogen to that carbon. Could have been carbons, but it's a hydrogen. And carbons here, I'll call R prime. And in this case, it's an acetal. And keep your eye on this carbon. The carbon with the 2 oxygens, carbonyl, what's attached to it is still attached to it. And then you'll get an alcohol. For those who must, you don't have to. You can put a 2 in front. Now, since I'm saying give the organic product or products, and I'm not asking to balance it, you don't have to put 2 there. So our prime, our double prime, our R. Keep your eye on this carbon. It becomes this carbon, which is a carbonyl, R prime hydrogen, R double prime ethyl, and my R group is ethyl. And for those who must, can I write it any smaller? You can put a 2 there. You don't have to. And that's how you do it. I said, this is a key reaction your stomach, Mother Nature, uses to break down carbohydrates in your stomach. And this reaction I'll never give as a synthesis. What 2 products will you get when you react that molecule with acid and water? I apologize for yawning. I didn't get a good night's sleep last night for whatever reason. So I've been up since about 4:15 this morning. I didn't get a good night's sleep tonight. I better sleep well. All right, let's take a look at this. What's different? What's not carbon? What's not hydrogen? Ooh, two oxygens on the same carbon. And I've got carbons here and here. I'll call R. And this carbon here, I've got carbons here and here. I'll call this R prime. Could have been a hydrogen, but it's not. And this I'll call R double prime. And when you react this with water and acid or acid and water, keep your eye on this carbon with the two oxygens. It becomes this. What's directly attached to it, R prime or R double prime, you get an aldehyde or ketone. And then from the OR, you get an alcohol. And for those who must, you can put a 2 there, but you don't have to. So this carbon comes this carbon. What's R prime? Ethyl. What's R double prime? Methyl. And what's my alcohol? Ethyl. And for those who must, you can put a 2 there. That's how you do it. Oh, I got to try another. Have you try another one? These are fun. And there you go. You take that molecule, react with acid and water. What's the product or products you get? Your turn. All right, looks like everybody's done. My turn. And if we look at this molecule, what's different? What's not carbon? What's not hydrogen? Two oxygens on this carbon. And it's got a hydrogen, but that could have been R prime. It's not. I tell you, the closer it gets to St. Patrick's Day, the worse my hydrogens look. Nah, they always look bad at times. And carbons here, I'll call our double prime. And this is an acetal or ketal. In this case, is an acetal. I'll never ask you the name. Water, acid. Keep your eye on this. Carbon with two oxygens becomes the carbonyl. What's attached to it, our prime or hydrogen, our double prime, still there. And from here, you get your alcohol. And for those who must, you can put a 2 there, you don't have to. It's funny. More than once, I've seen a student write it down, and they'll put the 2 in quotes like it's important. It's not. All right, here's my carbon here, which is this carbon, double bond oxygen. What's our prime? Hydrogen. What's our double prime? Methyl. Then my alcohol, what's our isopropyl? The carbon with the oxygen here will be the carbon with the hydroxyl group. The carbon with the oxygen R will be the carbon R with the hydroxyl group. And that's this one, the center of 3 carbons. And for those who must, you can put a 2 there, you don't need to. And that's how you do it. All right, let's move on. Well, we'll have to stop for a second. My machine burps at me and says, close Microsoft Word. All right, let's move on to a new reaction. And this is called the Grignard reaction, where you're forming, the first reaction is forming the Grignard reagent. And this is called forming the Grignard reagent. And here, X can be chlorine, bromine, or iodine. And what you make is the Grignard reagent, RMgX. This is magnesium metal. You usually do this in ether, but I'm not talking about reaction conditions. Now, let's talk about my personal hero, one of the great organic chemists. And that is the French organic chemist, Victor Grignard. Have you noticed he lived from 1871 to 1935? And he won the Nobel Prize for discovering his Grignard reagent and the Grignard reaction. And check out that mustache. Is that awesome? Because sometimes I have to go into a chemical plant for an emergency. I have to put on a gas mask. I can have a mustache like that or a beard. When I was in college, my beard was out to this. Once I started in the chemical industry, because safety in a gas mask, I keep it real short. But Victor Grignard, what a great, great organic chemist. One of my heroes in organic chemistry. So let's look at the Grignard reaction. It's a fun, easy reaction. You take an alkyl halide plus magnesium, you'll form the Grignard. Now, watch closely. Common mistake on test 2. Students write the Grignard that way. There's no such thing in chemistry. This is our group attached to the magnesium, and the halogen is attached to the magnesium, a Grignard reagent. And in my PhD thesis research, I used a Grignard. Remember, X can be chlorine, bromine, or iodine. And the question is, what's the organic product or products are the following? If we look at this, what's different? What's not carbon? What's not hydrogen? Should get your attention. Ooh, chlorine on carbons, alkyl halide. X can be chlorine, which is in our case it can, bromine, or iodine. Plus, ooh, magnesium metal. And you get the Grignard. What's our ethyl? Don't forget, it's magnesium first, not the halogen. What's the halogen? Chlorine. And we made that Grignard. Ethyl magnesium chloride is called. If I look at the clock, oh no, it's time to take a break. With that, let's take a 5-minute break. I can get up and stretch. I'll see you in 5. All right, we're talking about how to make the Grignard reagent. And you take an alkyl halide, RX, where X can be chlorine, bromine, or iodine, plus magnesium, and you form the Grignard. Remember, if you write it this way, it's wrong, and you'll get 0 points. Don't. All right. And remember, in here, the carbon with the halogen is the carbon the MgX is bonded to. The carbon with the halogen is the carbon the MgX is bonded to. Your turn. Give the organic product or products are the following. All right, looks like everybody's done. So let's take a look at what do you make, what organic product do you make when you react this with magnesium metal? And you look for what's different, what's not carbon, what's not hydrogen. Ooh, halogen on a carbon, alkyl halide. X can be chlorine, in our case is bromine, or iodine. Ooh, magnesium metal. And you make a Grignard reagent where the carbon with the halogen is the carbon the magnesium halide is attached to. What's my R group? This. You break carbon-carbon single bonds? No. So we have 1, 2, 3, 4, 5 carbons. I better end up with 5 carbons. Which carbon has the halogen? Will have the magnesium bromide attached to it. There are 4 bonds to carbon. This counts as 1 bond. And there you go. And that's the Grignard reagent you have. And I've done this reaction both in a teaching lab, a 2-semester. We don't do it in Chem 170. And also, I needed Grignard reagents in my research when I gave my PhD. Now, this is one reaction. I can do a synthesis problem. And the question is, what would you react with magnesium to make that molecule? And remember, please be patient. I give everybody time to finish. Finish. Oh, well, some people are finishing. But I thank all of you for making me a YouTube star. I see a lot of you are watching my videos. I hope it helps. All right, let's move forward. How do you figure out what do I react with magnesium, Mg, magnesium, to make this product? What's different? What's not carbon? What's not hydrogen? Ooh, magnesium with a halogen and carbons here. This is a Grignard reagent where X can be chlorine, bromine, or in our case, iodine. And what do you start with? An alkyl halide. What's our this? The carbon with the magnesium iodide or halide is the carbon with the halogen. And the halogen is iodine, which is on this carbon. And I'm done. And that's how you do it. Now, once you make the Grignard reagent, RMGX, what good is it? Why did Victor Grignard win the Nobel Prize in chemistry? Well, here's what's good with it. The Grignard reaction. And this is a two-step reaction. I'll explain that in a second. Take an aldehyde or ketone, and I don't have it here, I apologize. If R prime is hydrogen, it's an aldehyde. If it's carbon, it's a ketone. First step, reacted with a Grignard, are triple prime MgX. Remember here, X equals chlorine, bromine, or iodine. Second step, acid and water. And what you get is this alcohol. But notice right here, the Grignard, you do something very special, very rare in organic chemistry. You make a that's all good looking. You make a carbon-carbon single bond right here. And in all of organic chemistry, there are only about 20 or so, give or take a few reactions where I can make a carbon-carbon single bond. It's very rare. It's very good and important. And for that, Victor Grignard won the Nobel Prize, and his name has been associated with this reaction. Now, let me teach you something. I react A and B with something to make something, and then immediately I react that with C to make D. This is a two-step reaction. I'll never ask you on a test what's two-step reaction. Well, organic chemists are lazy, and neither easier way to write this is step one, you react A with B. And whatever you do in step make from that reaction, in step two, you react it with C to make D. And that's how we do it. Who started, I don't know, but we do that. So Grignard reaction, take an aldehyde or ketone, react it with a Grignard reagent, step one. Remember, X can be chlorine, bromine, or iodine. Step two, react it with acid and water, or I could have written water, acid, it's identical. And what happens is this attacks that and opens it up. It's protonated. Keep your eye on the carbonyl carbon. What's attached to it, R prime or hydrogen, R double prime. Opens it up to an alcohol, and you do that special thing. You make that carbon-carbon single bond. The carbon in R triple prime with the MgX is a carbon. This carbon is bonded to an R triple prime. And the question is, what's the organic product or products, excuse me, for the following reaction? By the way, this Grignard reaction, I will never give a synthesis problem on a test or a final. It's just too complex for this level course. But don't tell anybody I'm being nice. Shh. So let's do this. What's different? Ooh, oxygen bonded to carbon, carbonyl. They have carbons, R prime, but we can also have a hydrogen, and carbons here are double prime. Oops, excuse me, aldehyde or ketone. Our case, it's an aldehyde, because R prime is hydrogen, R double prime is methyl, I mean. Next, step one, carbon-carbon, ooh, magnesium halide. Bromine is a halogen. And we have a Grignard reagent. Remember, X can be chlorine, bromine, or iodine. In our case, it's bromine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it is still attached to an R prime or hydrogen, R double prime. And you get an alcohol, OH group, and then you do that special thing. You make a carbon-carbon single bond. And what's our triple prime? Ethyl. So I'm going to write this carbon, which is this carbon, which is this carbon. It has R hydrogen, R prime, double prime, ethyl. I say R, should have been R double prime, OH, and then I make that special thing, carbon-carbon single bond, and this is from my R triple prime. And I made this special carbon-carbon single bond. And Dr. White's happy. Whenever you can do that, that's a happy time. All right, your turn. And the question is, what's the organic product or products that you would get when you do this reaction, a two-step reaction? All right, my turn. What's different? What's not carbon? What's not hydrogen? Oh, oxygen, double bond to carbon, carbons here and here. A ketone. Now, it could have been an aldehyde, but it's not. Then, first step, what's different? Carbon, carbon, carbon. Ooh, magnesium chloride. That's a Grignard. Remember, X can be, in our case, it is chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it, our prime or hydrogen, and our double prime opens up to an alcohol. Then from the Grignard, you make that special carbon-carbon single bond, and the carbon on our triple prime with the Grignard, MgX, is the carbon this bond goes to. So here's my carbonyl. What's attached to it? Our prime, our double prime. Ah, I think I have R prime on the brain today. R prime methyl or double prime methyl. I'll have an alcohol, OH. And what's my R triple prime? And propyl, the carbon with the Grignard is the carbon bonded to this carbon. And this is the beauty, and it is beautiful in my mind. Obviously, others too. That's why I won the Nobel Prize. I start with a very simple ketone and a very simple Grignard, and I've made a very complex alcohol. And I'll teach you later, one of the more sophisticated places alcohols are used to make perfumes. Perfume industry is extremely complex organic chemistry and quite lucrative too. Oh, let's do another one. And there you go. What would be the product or products of this reactions? Two-step reaction. And I'm thinking about our syllabus and everything. We're right on track, right on time. Yay. Second test will be as scheduled. I think it's next week. Whoa. Now we're into really high level, exciting organic chemistry. Had to adjust my chair. All right, looks like everybody's done. My turn. Remember, I'll never give you a synthesis with this Grignard reaction. What's different? What's not carbon? What's not hydrogen? Oxygen, double bond to carbon. Carbon's here. Here is a ketone. Could have been an aldehyde, but it's not. And then over here, magnesium bromide. That's a Grignard reagent. Remember, X can be chlorine, or in our case, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. That's where the fun is. And what's attached to it, our prime or hydrogen, and our double prime is still there, hydroxyl group. And then remember, this goes here, opens it up, and then you put a proton H on there, and you make that very special thing, a carbon-carbon single bond. And the bond from carbon to the R triple prime is to the carbon in the Grignard with the MgX. Well, in a ring, a ketone, R prime and R double prime are the ring. So this carbon here will still be there. The ethyl will be there. This carbon here is this. It'll have a hydroxyl group. And my R triple prime is isopropyl. The center of 3 carbons. And that's how you make it. And guess what? I don't know of a simple, straightforward way how to make this compound that I just made if I needed it, unless you use a Grignard reagent. With a Grignard reagent, it's a piece of cake. I don't know about a piece of cake, but it's pretty simple. And that's the beauty, and that's the power of the Grignard reagent and reaction, which is why he won a Nobel Prize. All right, let's move on. Let's talk about hydrogenation of a ketone or aldehyde. If R prime is hydrogen, it's an aldehyde of carbon's ketone. And remember, carbonyl, 1 pi bond, 1 sigma bond. And like you learned in carbon-carbon double bonds, you can break a pi bond. And the catalyst, why did I get lazy? Should have written this down, sorry. And catalyst, like you learned before, nickel, platinum, or palladium. You break the pi bond, and each atom of the double bond gets a hydrogen, and you make an alcohol. Now, this is a neat reaction because Mother Nature has a lot of ketones and aldehydes that we can convert to alcohols that are in our daily products. And later on in the semester, I'll talk about one. And here we take an aldehyde or ketone. When R prime is hydrogen, it's an aldehyde. When it's carbon, it's a ketone. Remember, this has a pi bond we can break. And each atom of this carbonyl gets a hydrogen. And what was attached to it, R prime and R double prime or hydrogen, is still there. And the question is, what's the product or products you get for the following reaction? What's different? What's not carbon? What's not hydrogen? Carbon double bond to oxygen, carbonyl. And we have an aldehyde. R prime is this. Well, and it could have been carbon's a ketone. And then here, our double prime is an ethyl group. Remember, you have the pi bond, hydrogen, catalyst, catalyst can be nickel, platinum, or in our case, which is in our case, or palladium. And you break the pi bond, what's attached to the carbonyl carbon is still attached, and each atom of the carbonyl gets a hydrogen, which you could also write like this. Either way, it's an alcohol. So we look at this, what's attached to this carbon, which becomes this carbon, our prime hydrogen, our double prime, you get an alcohol. And I could have also written it this way. Remember, do you break carbon-carbon single bonds? No. Your turn. Give the organic product or products the following reaction. All right, let's continue. What's different? What's not carbon? What's not hydrogen? Oxygen bonded to carbon, carbonyl. There are carbons here. I'll call R prime. Could have been hydrogen. And carbons here, I'll call R double prime. Remember, this is a pi bond that you can break with hydrogen. And a catalyst, where the catalyst can be nickel, platinum, or in our case, palladium. And you break the pi bond, what's attached to the carbonyl carbon, still attached. And each atom of the double bond carbon oxygen gets a hydrogen. Well, in that case, here's our carbonyl. And what's attached to it are double prime methyl, our prime and propyl. And I break the pi bond, each atom gets a hydrogen. You could have written it this way also. And that's how you make an alcohol from a ketone or aldehyde. Oh, let's do another one. This one, I can do synthesis. What do I react with nickel and hydrogen gas, H2, to make that molecule? Remember, this is the fun part of organic chemistry. How do you make things? What do you start with? All right. Well, how do we figure out what to start with to react with hydrogen and nickel as a catalyst? Which could be nickel, platinum, or palladium. In our case, it is nickel. And what do we have here that's different? What's not carbon? What's not hydrogen? Ooh, oxygen with a hydrogen and a carbon. That's an alcohol. Which as soon as I see the hydrogen, I can write like this. Notice there are two hydrogens, so I can write our prime hydrogen, and then these carbons on this carbon are double prime. And what do you start with? An aldehyde or ketone. In our case, our prime is hydrogen, and this ethyl are double prime. The carbon with the hydroxyl is the carbonyl carbon. And one of our prime is a hydrogen, and that's how you do it. Now, I'm going to write something down here. You don't have to copy it down. And the question is, what if I wanted to make this molecule from this molecule? I say, oh, I don't want to lose my double bond, but I want to convert this into this. So you say, oh, I'll add hydrogen and nickel. And guess what? Wrong. Why? Because you've got two functional groups. I have an aldehyde or ketone that if I hydrogenate, I'll make this molecule, but I have a double bond. I break the pi bond here, and each carbon of the double bond gets a hydrogen. So what that means up here is this is the molecule I want, but if I break the double bond, I could make this molecule. And if I do both, well, let's call this A, B, and C. I'm trying to make C, well, I'm going to get a mess, a mixture of A, B, and C, which is going to make my life difficult. You don't want to do that. Well, how do we get around that? Well, it turns out another great organic chemist, Dr. H.C. Brown, Herbert Brown of Purdue, during World War II, came up with two new reagents. And one of them is lithium aluminum hydride, Li, lithium, Al, aluminum, hydride, H4. Now, think of in this molecule, the hydrogens, really hydrides, are like H minus, similar to Grignard. And if I take a ketone or aldehyde, if R prime is H, it's an aldehyde. First step, react it with lithium aluminum hydride. Second step, acid and water. Just like hydrogenation, each atom of this pi bond will get a hydrogen. Lithium aluminum hydride does not react with carbon-carbon double bonds. And it's important when you have that kind of dilemma to have a reagent like this, or if you can't use hydrogen as a catalyst, you use another one. And for this and another reagent, sodium borohydride, Dr. H.C. Brown of Purdue won the Nobel Prize many years after he invented this or just created this reaction, which was how should I say, caused a lot of anger in the organic chemistry toward the Nobel Prize Committee to the point where they finally gave it to him. And if I look at the clock, I have time to do one real quick. And the question is, what's the organic product? The product, what do we have that's different here? Carbon double bond to oxygen, carbonyl. I have R prime or hydrogen. R double prime. Reacted with lithium aluminum hydride, second step, acid and water. And it's like hydrogenation, but only does carbonyls. You break the pi bond of a carbonyl, and each atom of the carbonyl gets a hydrogen. Well, carbon, H, methyl, R prime, and R double prime are those still there. And I can rewrite this. And you make an alcohol. And now I look at the clock, we're almost done. Time flies when you're having fun with carbonyl compounds and Dr. White. Hope you had a great day today. Remember, Wednesday, the lab we did last week is due this Wednesday, actually Thursday, but get it on Wednesday. I'll be grading tomorrow, the last week's lab. If you haven't handed it in, please hand it in. And actually the week before, the one you handed in last week. I'll post the scores tomorrow. And with that, don't forget, Tuesday and Wednesday night, I have my office hours. So if you need help, stop by. It's on Zoom. And with that, I'll say, remember, in Yiddish, it means go in health, gehen gesund. Goodbye. I stole that from Granny. Bye.